Dear students, let's see this question. A rod of mass m and length L is free to rotate about point O. So here rod is there of mass m and length L is free to rotate about the point O. A particle having the same mass m moving horizontally with a velocity v0 hits the rod perpendicular at a distance L by 4 from the top end. So from the top end at a distance of L by 4, a particle of mass m hits perpendicularly and stops. After hitting, the particle comes to rest. Find the magnitude of impulse due to hinge on the rod due to collision. So very important point. Many times, if any mains question paper, if you want to stress, so you will use this word impulse due to hinge. Impulse due to hinge. So try to understand what is the meaning of impulse due to hinge. Impulse due to hinge is nothing but the change in the linear momentum of the total system. Change in linear momentum of the total system. Very important. Impulse due to hinge. Impulse due to hinge is nothing but the change in the linear momentum of total system. See here, I will write here. I will write impulse is denoted by J due to hinge is equal to change in momentum. Change in momentum. I will write change in linear momentum. It is not actual momentum. It is change in linear momentum. Change in linear momentum of system. It is not the particle, or if it is not the rod, it is the whole system. So now see here, initially, if you see the particle Pi, initial momentum is mass into velocity, right? Initial momentum. Particle, just try to understand. Here, particle is there. It is coming with initial momentum, and it hits. When it hits, the particle is coming to rest. So this one starts moving. This one starts moving. Clear? So we can write here final momentum Pf can be written as m into Vcm. Vcm. Vcm is velocity of center mass. Clear? So initial linear momentum is this one. Final linear momentum is this one. So if I can able to find out the value of Vcm, then I can find out J, nothing but impulse due to hinge. So further, one more point, see here, angular momentum. According to conservation of angular momentum, initial angular momentum is equal to final angular momentum. Initial angular momentum is equal to final angular momentum. Initial angular momentum m v0 into r. What is r? Perpendicular distance L by 4, which is equal to final angular momentum. Angular momentum of the rod. Angular momentum of the rod is equal to I omega. I into omega. So we can write here m v0 into L by 4 is equal to I. Moment of inertia of the rod at this hinge point. Moment of inertia of rod at the hinge point is m L square by 3 into omega. M L square by 3 into omega. So we can write m get cancelled. 1L will go. So omega can be written as how much it is? Omega can be written as 3 v0 by 4L. So 3 v0 by 4 into L. So I got omega. Omega is equal to 3 v0 by 4L. Now see here, in this situation, Pf can be written as m Vcm. V is equal to r omega. V is equal to r omega. What is r? Center of mass. At the center of mass, how much distance it will be? It will be L by 2. So I will write Vcm is equal to L by 2 r omega. So Pf can be written as m L by 2. Omega is nothing but 3 by 4 v0 by L. V0 by L. So this L will cancel. And again I will write Pf is equal to 3 by 8 m v0. 3 by 8 m v0. So what he is asking? He is asking J due to hinge is nothing but translational momentum. J due to hinge is nothing but change in linear momentum of the system. Linear momentum we have to calculate. So initial momentum is this one. Final momentum I got this one. So change in momentum is final momentum minus initial momentum. So I will write PF minus PI. So J due to hinge calculated as PF 3 by 8 mv naught 3 by 8 mv naught minus initial momentum. Initial momentum is mv naught here. So I will write it is mv naught. So J hinge can be written as 8 minus 3, 3 minus 8 minus 5 by 8 mv naught. 5 by 8 mv naught in magnitude wise. J hinge can be written as 5 by 8 mv naught. This will be the answer. So yeah, but this point is very important. J due to hinge means change in linear momentum of the system. Change in linear momentum of the whole system you have to calculate. So initially for the particle I calculated and for the rod I calculated the total change in linear momentum of the system. I hope you understood, right? Thank you.